Welcome to Semantic Web Technologies. This is lecture number 6, Applications in the Web of Data. And this is the last part of the last lecture of Semantic Web Technologies, and today we want to talk about exploratory semantic search. So this is something that is actually, or right now, topic of research. So this is nothing that you can buy out of the box in some store or something, or you will find on the web. So this is research stuff, and this is something which is really quite interesting, and it's based really on the semantic technologies that we have already covered within the last lectures of the course. So let's talk about exploratory semantic search. I will start the other way around. Of course, we know search on the web. We know Google. And we know with Google we might find everything on the web. But as I always say, there is something that is called the Google dilemma. And one thing is, of course, if you are not at Google or not on the first pages of Google, you will never be found on the web. So you are almost not there. So what is not at Google is not there, at least not at the web. But Google is quite good. We know that. So for example, if I'm looking for Aldous Huxley, who is British or was a British author, and when I type here Aldous, even before I finished typing, Google proposes me what would be most likely to finish my query string and gives me some answers here to the most likely answer, which would be Aldous Huxley. And this is something new from last year. Google also gives you results from the knowledge graph, which means whenever Google is able to determine an entity, a semantic entity within my query string, then this semantic entity, and this mostly refers to persons, for example, then you will find here on the right side of the screen, on the left side of the screen, sorry, you will find information about that person. You will find pictures, you will find here structured data, and you will find here, of course, books, because somebody wants to sell books too. Okay, so this is quite nice, of course. So the problem comes later. The problem comes here. Okay, you will see Google has some personalization. It gives me 5 personal results. Maybe they are important for me or not. But there are more than 6 million other results. And the problem here is, okay, has anybody of you ever looked until the end, until you reach the 6 millionth result? I don't think so. So the problem is, maybe you look on page 2, maybe you look on page 3, and so on. But somewhere you will stop. And most people stop after the first, after the second, or at least after the third page. Then there is nothing. So the first 20, the first 40 or 60 results, this is what counts. The rest, of course, is somewhere in the web and nobody cares for it. So this is one of the problems. To get an overview, what is really there on the web, you only get this number, which is an estimation. This is not a real number from Google. But you will have no idea what the 5th millionth document will be all about, unless you only know that it might be related to Aldous Huxley, but you won't ever find it here. That's the problem. But at Google, you do not only find text documents or text information, you also find, of course, multimedia documents. And for Google Multimedia Search, it's the same. Of course, you will find something about Aldous Huxley, but not because of an analysis of the video files here, for example. All these video files are on the web, and therefore they are placed within a web context. It means they are linked within an HTML page, and there in the HTML page you will have a title or something which links to this video. And there, of course, you see there is the name Aldous Huxley, and also here in the description is Aldous Huxley. And then again it comes back to text-based retrieval, so keyword-based retrieval as we know it. So also Google Multimedia Search works like the traditional multimedia approach. But there is also something new. Google is also able to make real multimedia search, so to search by media content. So this was an original image by or from Aldous Huxley, and you are able to find similar images at Google. So you will find, of course, the same images that are cropped somehow or have different sizes, but you will also be able to find the same person on other images that are closely or very similar to the original one. Of course, there will be also some pictures of people that are not Aldous Huxley and that are completely different, but this is only because they have some visual similarities. So here, really visual similarity search is done. And you will also find something at Google simply because the information resources they are dealing with are so huge. If we are dealing with a traditional closed archive, then also we have lots of documents, but we have a finite number of documents which is much, 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 much smaller than the number of documents we are dealing with on the web or with Google. So, for example, when I go to one of our search engines that we have implemented here, for example, Yovisto is a search engine for video lectures. So there are video lectures like the lecture you see here, and there are about 10,000 lectures from all about the world. When I here look for Aldous Huxley, for example, it might be the case that I will find no result. And this, although I have 10,000 videos, but none of them will be directly related to Aldous Huxley, or there will be directly a string written somewhere which states Aldous Huxley. Maybe it would be interesting for me to find, let's say, even British authors, or British authors who have written some utopian stories or science fiction stories. This would be, of course, interesting, but then I had to reformulate my traditional query string. Or the other way around is I should apply semantic technologies. And this is the point where exploratory search comes into play. So, what I want to show you today is that to search is not always alike. So it means searching is not always just searching. Let's take one example. So we stay with Aldous Huxley. For example, when I'm looking for the book Brave New World by Aldous Huxley, and also in a special edition, maybe in the first German edition, what do? I go to the library, and there I look it up in the index. And in the index, I might be able, for example, to find the index entry, where I will find here Brave New World by Aldous Huxley. I find here the publisher. I find here the year, 1933. I also have some additional bibliographic information, and I also will find the information where to find it in the library. So I will find a signature that says or tells me, go to this floor, go to this, go to this board, and then find the book with a number 34548, for example. And then I will end up with the right book, Brave New World, in the first German edition, which was in fact an English language edition, but it appeared in Germany. So this is the simple kind of search. Simple means I do know in advance what I'm looking for. I look here for a special book in a special edition. So this is something like I do on the web every day. When I go to Google, I look for special information, and I really know what I want to find. I know I want to find a document that contains exactly my query string. That's the point, so you know what you are looking for. But is this always the case? Just imagine what if you really liked reading Brave New World by Aldous Huxley, and now, what should you read next? Something similar, of course. But how do you phrase this in a search engine? In the library, it was quite simple. What you did do was, of course, you went to the friendly librarian, but maybe the friendly librarian who could give you the answer because she knew all the books and the topics and the content of most of the books. Maybe she's not there or has no time, then you might have a problem. What to do then? Then, of course, you would do the same thing that we do now for centuries. You would go to the library shelf, and you would dig into the shelf, look to the right, look to the left, where you have found your original book. And simply because of the categories and the systematic that is behind the organization of the shelves, you will be able to find similar topics, because mostly if you are not in the library magazine, but if you are somewhere where these books are somehow categorized by its content, then you might be able to find, for example, other utopian novels or science fiction novels in the shelf where you have found Aldous Huxley. So simply go there, get a look around, up and down, browse through the shelf. So this is something what we call exploratory search. So you have the problem, for example, you have no idea which query string to use in a search engine, simply because you do not know everything about the domain. The domain is completely new to you, and you have no idea how to phrase the subject, how to find the right words to express what you are really looking for. Or if you're looking for more complex answers meaning they are not answered with a single query string, but you have to do a first query to get information to phrase your second query, and then you get information to phrase your third query, and then you will be at the answer you were looking for at the point you were starting. So this is an iterative and complex process. If you want to get an overview over, let's say, a topic, then you need something where you can do browsing instead of pinpoint searching. And this is also a point when you browse through the shelves and you search something, maybe you will find something by chance that you haven't been looking for. And this is called serendipity. So this would be a nice and happy finding, a happy discovery. So this would be exploratory search. And the trouble that we have now, or the problem is, how can we enable exploratory search with the help of the semantic technologies that we've already learned about? I can show you how. So let's stay with our example. We have here the Brave New World. And of course, you will find in the DBpedia the information page and the ontology or entity of the Brave New World. And you will find lots of information about the Brave New World and her author. So what would I do next in the DBpedia? Of course, it's quite easy for me to get from the Brave New World to its author, Aldous Huxley. And then I can find, for example, more subjects that are connected via the same relation to the author. It means we can find other works that have been written by Aldous Huxley, like Point, Counterpoint, or for example here, The Doors of Perception or Islands, other novels of Aldous Huxley. But this is quite simple. Of course, this works in a library, and maybe you do not want to read other novels of the same author, or let's say these novels are not anymore in the library, somebody else has borrowed these books, so you have to come up with something else. Okay, let's stay with Aldous Huxley, and let's see what other authors are there that have a relation to Aldous Huxley. And you will get also this information from DBpedia quite easily. So, for example, you will find that another author, H.G. Wells, influenced Aldous Huxley. Or the other way around, Aldous Huxley influenced authors like George Orwell, and he also influenced other authors like, for example, Michel Houellebecq. So now it would be interesting to see what these people have written, and maybe there is some book that could be also of interest for me. But maybe they have written quite a lot, so what should I read next? Here also DBpedia provides an answer because there is a nice property which is called notable work, which means which are the books or the works that these people are best known for. And therefore, you will get the information that, for example, for H.G. Wells, you will find The Time Machine. For George Orwell, you will find 1984. And for Michel Houellebecq, you will find here the elementary particle. So atomized, it's called in English. So I will know what book to read next. But these questions were, let's say, or these answers were quite obvious. What is interesting here in exploratory search would be make me a recommendation of something that is not too close to my original query. Because if it's too close, then maybe I know already all about it and I want to be a little bit surprised. So I'm looking for some kind of serendipity. So now please surprise me. Just one example. I might find the fact that Aldous Huxley belongs to a class which is called English expatriates in the United States. And there are, of course, other people who are also English expatriates in the United States. So who belongs to this group? For example, Sir Tim Berners-Lee, and we know that Sir Tim Berners-Lee has invented the World Wide Web. So this is a nice, interesting connection that we were not in advance aware of. But maybe we are also not interested in it. We are computer scientists, so maybe this could be something interesting. But for computer scientists, you will find something more interesting. For example, you will also find this person here, which is Patrick Stewart, and computer scientists will know him because it's Captain Jean-Luc Picard, and then we are at our most favorite subject at Star Trek. So this would be serendipity, and firsthand, when you're looking for Aldous Huxley, I'm sure you have not thought about Star Trek. Okay, but let's go back to our example of exploratory search with Neil Armstrong. Here we know we simply have to follow the knowledge graph. We have done this already in the last part of the lecture to find also additional information which might be of interest for us, like, for example, Apollo 13, space accidents and incidents, or also the Challenger disaster, which is, of course, closely related to all these subjects. But here again, all these things are pretty close to my original query. What I want to do now, I also want to see some serendipity. And we found some serendipity related to Neil Armstrong, or better to Buzz Aldrin, who was one of the colleagues of Neil Armstrong in the Apollo 11 mission. And we have found there, and you can look it up for your own, there is, for example, an even longer path to the Cookie Monster because Buzz Aldrin once visited the Sesame Street. And what was also a surprise for us here in Germany, Buzz Aldrin also was on television screens last year in Strictly Come Dancing, this dancing television show. So I do not know whether he has won this competition show, no idea. But of course, this is a serendipitous discovery, so this is something completely new and maybe interesting for you. So this will be something which you don't reckon to find or do not thought about finding this in the first hand. It might be interesting for you. So this is the way in principle how it works. Okay, how do you get this into a user interface for a semantic search engine? So this is quite difficult. We tried this several years ago in an exploratory search interface for the Yovisto search engine. So what we did there was, besides the regular search results that you see here, we provided another panel where for the original query, you found things that were related with our original query and that were available within our archive. So for example, we have here looked for George Orwell, and George Orwell is related to London, and we have 83 videos that are also related to London. I will show you this as a live demo. Okay, this is the prototype application that you can also access and try out on the web. And what you have here, for example, you can here give your query string, like in a traditional information retrieval system. And for example, we can try, for example, to look for another author, for example, for Ernest Hemingway. And we will see what happens. So here again, you see here the results for Ernest Hemingway. So these are lectures that are somehow related to Ernest Hemingway. And what is more interesting is here on the side. Here on the side, you have the panel with the exploratory search. So for example, it says that Ernest Hemingway wrote in the genre of war novels, and we have one additional video that is related to war novels. Then you can see that Ernest Hemingway himself, he influenced other peoples like Charles Bukowski, Jack Kerouac, or Harold Pinter. And we have also videos that are related to journalism or to authors. And you will also see people who have influenced Hemingway. Let's take a look what happens if we are choosing journalists. So I click on that. And then here again, in the middle, you see results that are somehow related to journalism. And you see here, again, suggestions or recommendations, what you should look for if you are not content with the results that are related to journalism. So for example, you might find here other things that are related to feuilleton, magazine, documentary, film, and stuff like that. Photographer. Let's take a look at photographer. What happens there? And again, you see here, you will have, again, videos that are related to photographs or photographers. And you have, again, here in the exploratory search panel, you have here other categories that are related to photographer. And of course, photography is related to photographer. Or also paparazzi. This would be interesting. What happens if I click on paparazzi? You see, we will find something which is related to paparazzi, but not paparazzi as a photographer. This is paparazzi, a software system. So it's also quite interesting. And then you see other things that are somehow related to paparazzis. And there you will find, for example, Brad Pitt or also Arnold Schwarzenegger. And now it will getting much more interesting. So this is an example for a really simple implementation, a recommender system, what you should search or what your archive could provide if you are not content with the direct results. So it's an exploratory search experience. So this was a short overview about exploratory search technology, which is ongoing research. Okay, and right now we have reached the end of lecture 6, and therefore we also have reached the end of our course, Semantic Web Technologies. Of course, we have only scratched at the surface. You can dive much deeper, or you can dig much deeper into the subject, especially if it comes to logic, if it comes to reasoning, and then also if it comes to programming. But I hope we will have given you a good starting point to develop your own skills in semantic technologies, which are an upcoming topic, or a rather recent topic, which becomes now slowly much more popular within the web. So we will give you on the reading materials also some books where you can continue your lecture with, for example, programming examples, semantic web, not only from the theoretical point of view, but also from the practical point of view. So it will be programming the semantic web and, for example, ontology engineering on a more practical level, and we will give you some reading advice for that. And I hope you have enjoyed the lecture, and maybe we see you again. So thank you and goodbye.